Alright, so in exercise 4I in Patel in question 3b, we are required to prove that A plus B omega plus C omega squared over C plus A omega plus B omega squared is all equal to omega squared. So, because omega is the complex cube root of unity, we know that we've got omega cubed equals to 1, because the cube root of 1 is omega, so omega cubed is 1. Now that's a very important statement, because knowing that means we can put omega cubed wherever we like into the question, and doing that makes it quite straightforward. And that's because we can just chuck an omega cubed in the top without changing anything, because all we've done is put in a factor of 1, and putting in a factor of 1 changes nothing. But more importantly, on that left hand side that we just named, we can now manipulate in omega in a way that is useful for us. So instead of leaving all three of them out the front, I'm just going to leave a squared out the front, and that the reason I'm doing that is because I get A omega, which is in the denominator, plus B omega squared, which is also in the denominator, plus C omega cubed, which isn't yet in the denominator but is going to be. All of that is over C plus A omega plus B omega squared. But in addition to that, C omega cubed, well, omega cubed is 1, as stated up in that second line, which means that that's just C. And so we're left with omega squared outside of A omega plus B omega squared plus C, as omega cubed equals 1, and that's all over C plus A omega plus B omega squared. And now you can see that the denominator and the bracket are exactly the same, and therefore are fully divisible by each other, and that leaves us on the left hand side with omega squared. And therefore left hand side equals right hand side equals omega squared, and A plus B omega plus C omega squared over C plus A omega plus B omega squared equals omega squared.